So hello, today I'm going to make a little webinar about cryptography in our statistical software. My name is Vladimir and I'm doing this webinar to help others to understand what is cryptography and how fun it can be if combined with our statistical software. So this webinar will be about 20 minutes and I'm going to show you live how to use cryptography without installing any locked software. All we will be using is our statistical software, our studio, and a little bit of code that is you can get for free. So let's just basically start it. I have prepared a little presentation. I will share my screen and we will get started. So this is my presentation here. I just need to make screen share, right? So, all right, so let's get started. Here's my presentation here, and here we go. So the live webinar about cryptography. This is what we are doing. When you want to do this, so when you need this, well, it might be use of, for example, to protect your passwords, to not to keep passwords in open code in public repositories on GitHub, and many other features. So let's get started. I hope you can see well and hear well. So please scream out if you type a message. If you don't, I think you should be feeling fine. Now, there is what I'm doing. I would just like to give you a little introduction to my website. This is a website that I created mainly to promote what I'm doing. It is about how to save your time and let computers do the job. There are several in this website. You'll find several works that I published. This is about several topics. One of them, lazy trading. Another one is cryptography. There is something about save your time by collecting data with Excel, and particularly this one is about cryptography is more fun with R. There is a course which you can access from here. This course is very well detailed with very detailed information, explains how to use public key cryptography. It's not that big course, but it is providing a lot of different use cases of using public key cryptography in R. So make sure to check it out and let's get started. Let's continue. By the way, on this website, you can also find a blog and you can read other articles. Now, a little disclaimer before we start. All methods are basically provided for learning purposes. There is a risk of losing data because you have to know what you do. There might be different situations. So the recommendation is to try on the dummy data first. And then another thing that I would like to highlight is that check laws on your country if you're eligible to use cryptography. That is it. Now, very short theory before we go practical. The public key cryptography is all about having a key, private key, and with this sets of key, we can encrypt and decrypt information. The method is going like this. We have sort of a secret owner and some people that shouldn't read information and exchanging party. Whenever we go blue here, we are actually we have information decrypted, and once we passing this information through some encrypting protocol, we are encrypting this information, make it illegible for adversaries. So all the method of using public key cryptography is all about encrypting and decrypting information. So encrypting means we cannot read it, and decrypting it, we may read it back. Public key cryptography can be explained like this. We have one person here on the right is having a private key. This person is sending this key to another person, and this person encrypting this information and sending that to that person on the right, and only that person on the right can then open this message, encrypted message. Now I would like you to copy this link or click in it, and there will be this will be a repository for this webinar. I have already I already have it in this RStudio session right here. So this repository is basically contained here. Just make sure to get it. If you're watching it later, just pause the video now and once again go to this website, github.com, use this link which you have, and simply clone or download a zip and get this code. Okay, so we have still 15 minutes to go. So once again, this repository contains several scripts, and now our idea will be to go through them. Okay, we will start with basics, with creating keys. Okay, so just open the script tutorial keygen.r. I will make now this much bigger, so you will be able to see it better. Here we go. One more time, zoom in, and I hope you can see that much better now. Okay. Now, to start using cryptography from R, we need to install one key package, which is OpenSSL. Let me just execute this code to do that. This package contains functions that will allow you to use cryptography using our statistical software. So no installation of locked software is necessary. And then another package which we'll use is tdverse, which is basically the package that is contains different useful functions for data manipulation. Now we will start loading those functions to the environment. And another one right here, we have those packages loaded. And now, if you are curious to read functions and help about OpenSSL package, you can just execute this code and you'll have this description. It tells that the OpenSSL package here is providing entire toolkit for encryption, signatures, and certificates. There are different help here, which you can also read independently, but nevertheless, we can just execute this code to make a thing really clear. So now, what we'll do now, we will first of all generate the key, and we will first line of code, we will create key in the directory which will be inside our repository. So what this code will do now, it will generate a folder, right? This is an empty folder at the moment, so we're just generating it. And now we will write a private key to this folder. So right now I will just execute this, this piece of code. And right here, we have our key. This is a private key. It's already generated, so we don't have to make anything. By the way, you can pretty much decide how big this key can be. For example, if you want to specify this number, it will be default value, so the key will be pretty short. But if you can make it very, very big. Right, so this size of the key will now be increased. Okay, for example, before it was 4 kilobyte, and now we're generating much longer one. It is still running the code. By the way, the larger the key, the speed will not change of encryption. This will be not dependent on that. It's still running, probably too much. Let me just stop it and something smaller. Wow, it's still running the code. Terminate. Yes, let me terminate. Something get wrong. Sorry for that. Let me just restart everything and just start doing it again. So let me just run this code once again, and just here we go. We have our keys. This is a key. If I put here 7,000 bit, it will overwrite now this key, and the key will be slightly bigger, as you see here. Now, I would like right now to actually generate a public key, and later we will want to understand what is inside of them. So this code will read this file here, and later extract a piece. This one like this. We can read this key, and this is the signature of this key. And if we go next after the pipe like this, it will give us the this will be the public key element of this. And if we run further like this, we just simply write a public key. The part of the private key is known to be a public key, and but we will be able to see that. So let's do like this. We will now generate an object. We call it private underscore key by reading the key and assigning it to this object private key. Right. So let's do this, and we have an object. Right. This is sort of a list, but we can see its structure here. Just do like this, and this is the piece of information here. So this is our actually private key. This is very, let's say, confidential information what we have here. And here we go. We have this public key element here, and the we have also this public key containing sort of information about this, but the secret information which is stored somewhere here around. But let's go step by step, and let's actually read also public key as well. So here I have a public key, and let me see now the structure of the public key. So if I look down both together, I will be able to see that actually this part, module E and N, is common, right? E and N is the common in both, right? But in the private key, we have those elements, those numbers that are secret. They basically, this is a big random number which is generated, which is defining the security of our application. All right, let's go further. And at this moment, we know a little bit about the private and public key. We can well. What is interesting here is that this key has a signature. This is a signature. We can extract this signature by running the code. For example, private key $ pub key dollar SSH. So this will be our signature of this key. So it's kind of a hash which is unique for our key. Then there are other elements like fingerprint, which is a little bit less secure hash, but then we have other elements like data. Data is a random number. Let's just repeat this instead of um, looking for, let's look for data and look for element E and see what it is. It's so this element E is a big number, right? And this is 65537 and so on. So right now, however, what we have here, what we achieve is to get consistently written object, private and public keys, and we can just remove those objects from here completely, right? So what we achieved just now is to have our keys generated, right? This is all you need to know at the moment. The important thing is that those keys are now unique. If you're gonna use it seriously, please check out my course about cryptography. or let's say read more about this, because this is unique key. You have to probably back it up. I recommend you to maybe save that to USB stick and have maybe a management system, how you would manage, how you would replace them. This is very important. Now, we are gonna now talk about how do we use those keys, for example, for encryption. So now I have another script. Please open another script which is called tutorial underscore encrypt. And here you have this another script. If you want to start from scratch, just execute this code. And what we're gonna do now, we will encrypt phrase "Hello World" and write it to the to this place, right? To this to our repository. Well, how do I do that? First, I will read this information, this string, and then I will serialize it. Make sure to reproduce this code like this. So by serialization, what we do, we kind of creating this raw data vector, right? And then we use this code, we're passing it to the function encrypt underscore envelope. To this function, we just need to provide the path to our public key. And here we go. What we can do is like this. This will be our encrypted information, right? This is our encrypted information right here. This is completely encrypted. It's not possible to decode it without having a private key. So this information we will exactly write to the file, which we call message.enc, which stands for encrypted. Well, you can definitely choose any name you want, actually. Right, now we have this piece of encrypted information, which is containing the message hello world. And this message is well protected. You can send it by mail, you can put it on the cloud. Well, nobody will be able to read it without private key. Now we will go back and decrypt it, and we will do that with other script. But before to doing it, let me just maybe write it like this. Let's make another trial. Let's encrypt message hello world, but now we will use private key. Okay, here is the private key object, which we will persistently read, and I will create message one encrypt. Look how quick it is to actually encrypt information. Very, very quick. And next step we will be doing actually is to go and decrypt this information, right? So to code to decrypt information is also not that big. In fact, it's very short. And here we go. This is the code you need to actually first we read this information by using this code read underscore RDS. We read this information, and then we go and just provide this code. And if we do like this, we have a row vector, but we can, if we unserialize it, we have our hello world example. Well, if I do it like this, if I take the message one and I execute this code again, I will obviously have the same result. And this is it. This is how we encrypt and decrypt information. This was a very quick tutorial about how to use cryptography in R. Very basic. Once again, make sure to visit my website and check the course. Make sure to like this video and share it on your personal private preferred social networks. So this was it, and thank you for watching. I'm looking forward to come back with other videos like that. See you soon. Bye.